Welcome back, students. Today we will be discussing the concept of line and phase voltage as well as current. As you all can see, I have taken an example of the star system. So I have taken both the star load as well as the star source. So here you can see I have marked some points with red marker. Your ZR, ZB, ZY indicates the impedance of your R phase, Y phase and B phase. If you directly see, you can find it out that your R dash makes one phase, Y dash second and B dash third phase. So if we check out that the difference between R and N will always be a single phase, B and N will be a single phase, Y and N will be a single phase. But when we talk about R, Y and B, these are the lines through which the source feeds the load. So anything when we are talking about is between R and Y or Y and B or B and R becomes a line. Either it is a voltage, either it is a current. So let's discuss them quickly. So I have drawn all the markings here. If you directly see, here I have marked all the coils R dash, B dash, Y dash. So anything if I'm going to talk about R and N will make it to be a phase voltage, while Y and Y dash will make it to be a phase voltage of the Y phase. Similarly for B phase. So here I have marked your lines R, Y and B, and I have taken the neutral also so that the concept is more clear. So I have taken, now you should answer it by yourself that what will be the voltage between R and Y. As I have discussed, between R and Y you always have to go for the line voltage. So here VRY will become a line voltage. Similarly, the voltage between B and R lines will become a line voltage, and similarly between Y and B will become a line voltage. But what about the phase voltage? I have taken with respect to the neutral. So the difference of voltage between this neutral point and the single line R will make it to be a phase voltage. Similarly, VYN will make it to be a phase voltage, and VBN will make it to be a phase voltage of the phases R, Y and B. So I have just summarized all the values here. Directly you can see that VL is VRY between two lines, between two lines, between two lines, all are the line voltages. We have already studied that VL is equal to under root 3 of the V phase voltage. So here we have to calculate the V phase because line voltage will be given in every numerical. We will be discussing one numerical after this. So here you can see that VL is equals to under root 3 V phase, and V phase will become VL by root 3. So I have put here the values. So the phase voltage of VRY and B will become VR will become VL by root 3. VL will be given divided by root 3 and take angle 0. The next same thing minus 120. This is for the balance systems. So there is a quick way to remember that in a star system your IL is always equal to I phase. How? This is my line current coming. IR will come here in this R phase and it will go to the neutral. Similarly, IY will come here and will go to the neutral. Similarly, this IB will come and go to the neutral. So that means whatever was coming on the line is going to the neutral point. So that means the current in this phase with respect to neutral is only the line current. You can go again with this. IR is the line current. Whatever is coming on the R line, Y line and B line are the line currents or the voltages. Between two is the voltage. So this is the line current. When it is coming in my this single phase R, it will be moving towards the neutral. Similarly, Y coming here will be moving towards the neutral, and similarly here. So the current in this phase will be only the IR current. So that means the line current IR is nothing but the phase current. Similarly, IY that is coming on this line is the phase current. Similarly, this line current IB is the phase current. Now we come on to your line voltages. We can see that the voltage between R and Y, if we just check it out the points, it will be between these 2 points. So it directly indicates our mind that there should be some relation between line voltage and the phase voltage. And the relation we already know, that the line voltage is always equals to under root 3 times the phase voltage. So it can be directly solved in the numericals, and there should be no confusion. For star system, IL will always be equal to the I phase. So now we come on to our delta system. You can see here that our delta system is having the delta source as well as the delta load. Now here we have to first keep in our minds that what is the relation between the line and the phase voltage here, and line and the phase current here. The concept remains same. Whatever is coming between the lines is our line voltage, and whatever is coming through the lines is our line current. So we all know that VL is equals to V phase in delta, and IL is equal to root 3 I phase here. But I am going to give you a quick concept over here so that you shouldn't confuse in the numericals. So here I have taken the delta system here, and just check it out here that this is my line voltage between R and Y, and just pinpoint the points here. If I'm going to point it out here, this is nothing but the phase voltage of my R side. Similarly, VY by VYB is going to give me the phase voltage of this point, and similarly the line voltage VRB between these 2 points is going to give me the phase voltage of this. This is a quick way to remember that what is the relation between the line and the phase voltages in delta as well as the star connection. So we can just see here that between these 2 points is the line as well as the phase. So that means VL will always be equal to V phase. So if this is equal, so that means there must be a relation between line currents and the phase currents. So the relation of root 3 always exists, because from the phasor diagram, if we draw it in the opposite direction, the relation comes from there. So here we come on to our first numerical. So if you just read it carefully, a star connected load of impedance 3 plus J4 in each phase is connected to a 400 volts 3-phase supply. Find the phase voltage and the line currents. So the two things that you should carefully notice down is what connection type it is and what is the voltage that is coming on the lines. So from here it directly comes out to be the line voltage is coming out to be this. So now we know that it is a star connected system. So there will be a relation between your VL and V phase. Your VL is equal to root 3 V phase, that makes it to be V phase equal to 400 by root 3, that is 231. So that means the voltage coming at each phase is 231. I have written here only the differences of the angles because this is a balance supply. Now we know we have to now calculate, we have calculated our phase voltages. Now we have to calculate our line currents. But for that we should calculate our phase currents. How? We have got our this star system. Now we know the voltage here, we know the impedance here. So if we know V equals to IR from the Ohm's formula, if we know this, we can know the phase currents, right? So here, by putting the value of phase voltage and this, I will be rubbing it because I am taking it in general, 231 divided by 3 plus G4, where this is your impedance and this is your voltage, because after getting the value of this we have to only add the angles to get our value of the phase currents. I think you all know that your this form is the rectangular form of the form a plus jb. So wherever is the rectangular form, we always have to go for your addition and subtraction in this form. But if we have to multiply or divide, we have to first convert your this form into the polar form, that means r angle theta form. So that means we have to convert your 3 plus j4 into its corresponding polar. So I have kept the calculator here. So all those who don't know, we have to just feed here what we want to convert. We want to convert this into the polar form. So I will be pressing the polar here. Now I want to convert 3 and 4. So that means I only want the numerical part here. 3 comma 4 I am going to write 3 comma 4 equals to. So this is directly the polar form coming. So that means 3 plus j4 is equal to 5 angle 53.13. So I'm directly going to put the values here to get my I phase here. This provides me with this value 231 upon 5 angle 53.13. This will go to the numerator term as this, because the angle in the numerator is 0. So 231 divided by 5 gives me 46.2. So my I phase is coming out to be this. So now we have to put the angles of B and Y here, and we have to calculate your corresponding values. This value is for your reference phase, that is the IR. So here come all the values of my rest of the phase currents. Once the phase currents we have got, so we know that our line currents are equal to the phase currents. So these are going to be the values of the line currents as well, but the line currents lags the phase current by 30 degrees. So we have to deduce minus 30 from all of them. So this is all. So now I have taken the example of a delta load. So here what I have to again circle is delta and 400. I have taken the same numerical so that the concept is more clear to you. So now because this is a delta system, that means that VL will be equal to V phase. So that means the value of V phase will directly be equal to your this line voltage. Now we know the phase voltage of every phase and we know the impedance of every phase. So we have to only divide to get the phase currents. But here the relation is between line and the phase currents. So we have to first calculate them and we have to then multiply all of them with under root 3 to get the value of our line currents. So I think the concept is clear to you. That's all, and have a good day.